Hello, geometry folks. All right, so today we're going to do a little departure from the norm. Over the next 2 weeks, what we're going to actually be doing is reviewing concepts that we think is important in preparation for the SAT and those types of exams. For the next 2 weeks, we're going to go over topics like systems of equations, factoring, proportions, trigonometry, absolute values, exponents, and things like that. So today what we're going to focus on is solving systems of equations. So all these topics, there's nothing that's going to be new. We're just going to just reinforce those topics on the first day of each one of these, I guess, sets of days. And then on the second day, we're going to focus on SAT style problems to just help you get acquainted with what you're going to see on the exam in preparation for the PSAT and the SAT. All right, so today and tomorrow we're going to really be focusing on solving systems of equations, because that's a huge part of the SAT. There's a lot of problems that go over systems of equations on the SAT. So let's begin. Just so the first couple of things that we go over, like I said, there's really nothing that's going to be new. I'm just going to kind of reteach this. Most of you guys have seen this from your first time through it in Algebra 1. So we're just going to, strengthen our skills and then go over SAT problems in the second day. All right, so methods to solve by substitution. This is the first method that we're going to focus on and use. So first, what we're going to do is we are going to solve one of the equations for either x or y. Once we get x equals or y equals something, we're going to take that answer from step 1 and substitute it into the other equation. So we're using one equation to solve for x or y. Once we've solved that, we're substituting this value in for either x or for y and substituting it into that equation. That'll allow us to solve for one of our variables. So then we're actually not done yet. We don't have the answer yet. Once we have solved for one of our variables, we're going to take that solution. Oops. Undo that real quick. We're going to take that solution and substitute it into another equation. It actually doesn't matter then at that point what equation we substituted into to get the other variable. Once we're done, we're going to write our answer as an ordered pair. All right, so let's try out this first example. All right, so in example 1, we have y equals -7, and then 4x plus y equals 9. So in this one, we've actually already skipped a couple steps here. Okay, we already know that y equals 7. So if y equals 7 in this scenario, we could just substitute -7. We can substitute -7 into the second equation to help us solve for x. All right, so we have 4x plus -7, or just -7, equals 9. And then add 7 to both sides, and we get 4x equals 16. We have 4x equals 16. To get x by itself, we divide by 4. We get x equals 4. So now we have the x value and we have the y value. We're going to write that as an ordered pair, which would be the x comma y ordered pair. So 4 comma -7. So 4 -7 is our ordered pair there. All right, for part B, pretty similar, except we don't explicitly have one of the values yet. However, in this first equation, this equation is already solved for y. So once again, we've already skipped some steps here. We have y equals x plus 3. So we know the value of y. Although we don't know what x plus 3 is yet, we know y is the same as x plus 3. So if y is the same as x plus 3, we can substitute x plus 3. We can substitute y with x plus 3 in that second equation. So if we rewrite this, and notice I did put parentheses around x plus 3 because we got to plug that whole thing in. So we have 3x minus this whole thing. Those parentheses are really important, right? Because not only are we subtracting x, but we're also subtracting 3. We're subtracting that whole thing. So I'm just going to rewrite that. So 3x minus 3. We distribute -1 to both of those. Now let's combine like terms. We get 2x. All right, isolate the variable. So get our variables on one side, constants on the other. So that means just add 3 and divide by 2. And we get x equals 4. All right, so we've got one of the values, but we still need to figure out what y is. All right, since we have x, we can plug x into either one of these equations. It actually doesn't matter where we plug it into because we'll be able to solve for y no matter what because we'll only have one unknown. So the easiest equation to plug it into would be that equation in which we've already solved for that other variable that we're looking for. Okay, so if we replace x with 4 there, all right, we get y equals 4 plus 3, which is 7. So that means our solution is the point 4, 7. All right, so those are two basic examples using substitution. All right, one in which we already had one of the values, the other in which we already had a variable isolated on one side. All right, let's scroll down to the next two. I'm going to clear the board here. Let's go down to parts C and D. Got a little bit more writing space for these. All right, so if we take a look at part C, once again, we get this occasion in which we already have one of the variables isolated. All right, so in that case, we could just substitute y with negative 2x minus 6. So y in that other equation is right there. So we're going to put negative 2x minus 6 in parentheses, that full quantity right there. So I'm going to rewrite this equation. And instead of y, we're putting negative 2x minus 6. All right, so now next, we've got to simplify this equation. So let's distribute that negative 2 to both terms. So negative 2 times negative 2x would be positive 4x. Negative 2 times negative 6 is positive 12. Combine our like terms here. We get 5x plus 12 equals negative 13. Subtract 12 to get 5x by itself. So we get 5x equals negative 25, and divide by 5 to get x by itself. So we have negative 5 as our x value. So now that we have one of the values, okay, we can plug that value into either one of the equations. But once again, like I said, this is going to be the easiest equation. This is already solved for y. So if I replace x here, right, and write negative 5, instead, we're going to have y equals negative 2 times negative 5 minus 6. Negative 2 times negative 5 is 10. And then 10 minus 6 is 4. So that gives us a solution, negative 5, 4. All right, let's check out part D here. Just going to pick a color to differentiate so we can keep all this work separated from one another. So in part D, we have y equals 2x minus 3. So instead of y in that second equation, we're going to substitute it and write 2x minus 3. So we have x plus 3 times the quantity 2x minus 3 equals 5. Now we're going to simplify, so let's distribute. We get x plus 6x minus 9 equals 5. Combine those like terms. Right. Add 9. Divide by 7. We get x equals 2. Now with that 2, we're going to plug it in right here. So y equals 2 times 2 minus 3. All right, so that would be just 4 minus 3, or 1. So our solution there is the point 2 comma 1. All right, so that's what we've got for substitution. Now we're going to move on to elimination. So once again, going to clear the board, going to move on. So now we're going to use elimination to solve some of these problems. Now, in most cases, we can use substitution or elimination to solve these systems. Sometimes it's easier to use substitution, sometimes it's easier to use elimination, and a lot of times it's based on your own preference. But what we're going to do is we're going to use elimination on these so that we can get 4 examples of each. All right, so for part A, we want to use elimination. Now, in order to use elimination, we have to create a set of opposites. All right, in terms of the x's or in terms of the y's, we need a set of opposites, because elimination is all about combining these 2 equations to cancel one of our variables out. Now, if we combine these 2 equations, and I'm just going to write this down, and then I'm going to erase it. If we combine these 2 equations, negative 10x plus negative 2x would be negative 12x. 3y plus 5y is 8y. And then negative 3 plus 13 would give us 10. Notice we haven't canceled anything out. This doesn't get us anywhere. All right, so that's not what we want to do. All right, what we want to do is create a set of opposites. Now, when we're creating a set of opposites, what we want to do is look at common multiples between the variables, the coefficients in the variables more specifically. All right, so if we take a look at 3 and 5, right, if we just write out some of the first multiples that we have, the first common multiple that we would have there would be 15. Okay, now that's if we wanted to cancel out the y variables. All right, we would have to multiply that first equation and multiply that second equation to create a set of opposites. All right, that's not the easiest case in this scenario. In this scenario, we could actually find a common multiple in the x's much easier. All right, so 10 is a multiple of 2. Okay, so what we've just got to do is we've got to make this into a positive 10x, because negative 10x plus positive 10x would cancel out. That would give us 0. It would cancel out the variable. So we want to multiply the second equation by something that's going to give us positive 10x. All right, so if we multiply this equation by negative 5, and that's the whole thing, everything included, if we multiply that by negative 5, we'd get 10x minus 25y equals negative 65. So now when we combine these 2 equations, the x is going to cancel out. So if we combine these 2, negative 10x, cancel out that positive 10x. 3y plus negative 25y is negative 22y. And then negative 3 plus negative 65 is negative 68. All right, now we want to solve for y. So we would divide by negative 22. So we'd get negative 68 on negative 22. And if we simplify that fraction, that'll give us 34/11. All right, we're kind of starting off with a difficult example in terms of dealing with fractions here. All right, so y is 34/11. Now we've got to go back and figure out what x is. Now this is just taking up where substitution left off. All right, so we take this value and we can plug it into either one of those original equations and then solve for y. So it's up to you. It's up to you what equation you'd like to plug it into. Okay, so I'm going to choose to plug it into that second equation just because, you know what, we've got negative 2x and that's what we're going to be solving for, so we're just going to have to divide by negative 2 when it's all said and done. in order to solve for x. So instead of y, I'm going to put 30, I'm going to substitute it with 34 over 11. So we have negative 2x plus 5 times 34/11 equals 13. All right, so you can see we've got some rather complicated work with fractions to do here. All right, so we'll have to distribute that 5 or multiply 5 times 34. All right, if we do that, we get 170. Now we're going to have to subtract 170 on 11 from 13. Now the easiest way to do so would be to figure out how many 11ths is 13. All right, we could just do 11 times 13. And we'd get 143 11ths. Now we're going to subtract 170 11ths on both sides. So if we do that, we'd get negative 27 11ths here. Now from there, to solve for x, we would divide by negative 2. So we have a negative divided by a negative, which is going to be a positive. And really, when we divide by 2, instead we could just multiply by 1/2. So if we multiply by 1/2, you can see that 2 is just going to multiply by the denominator there. So we have x is negative 27 on 22. All right, so our solution here is negative 27 on 22, comma 34/11. So like I was saying, this one's a tough one. All right, that's kind of a doozy there. All right, the other examples in the notes are going to be a little bit easier. Okay, so let's try out the second one. So in the second one, we already have a set of opposites. If you look right here, okay, these two are opposites. If we combine these two equations, that y is going to cancel out. So that's what we're going to do. Negative 10x plus 5x will give us negative 5x. Negative 5 plus negative 15 is negative 20. Then we'll divide by negative 5 on both sides, and we get 4. All right, then from there, all we have to do is just plug that 4 into either one of these equations. It's up to you. It doesn't matter which equation, you'll still get the same value for y in the end. So I'm going to plug it into the second equation. So we would have 5 times 4 plus 5y equals negative 15. All right, so that's 20 plus 5y equals negative 15. Subtract 20. We get negative 35. And then divide by 5, and we get negative 7. So our solution here is 4, negative 7. All right, we got we've got a few more examples to go over. We've got 3 more. All right, I'm going to clear the board and scroll down. If I can get this thing to work. All right, C and D. Let's try those two out next. And just for fun, I'm going to choose a different color again. All right, so in this case, just like the first case that we went over using elimination, we don't have a set of opposites right away. So it's up to you whether you want to cancel out, if you want to attempt to cancel out the x's or the y's. That's up to you. Just know that you need to create a set of opposites in one of the variables. All right, so what I'm going to do is I'm going to shoot for canceling out x's. The reason why I choose that, these coefficients are smaller. All right, so it's going to be a little bit simpler probably to create a set of opposites. So this is negative 2x. So positive 2x would be its opposite. So we just got to multiply the second equation by something that's going to give us positive 2x. All right, so negative 2 times negative x would give us positive 2x. So that means we're going to multiply this entire equation by negative 2. So let's go ahead and do that. I already did that for negative x. Negative 2 times 4y is negative 8y. Negative 2 times negative 17 is 34. Now we have a set of opposites in these two equations. So now we're going to combine these two equations. A lot of times I see people just copying this equation down and just writing it right underneath. All right, and that's, I think, a good method. All right, you get less confused by what's going on over here, and you could just see these two equations right beside each other, and it's a little bit easier to combine. So all we have to do is just go straight down as long as the x's, y's, and constants are all matched up. Now we're going to add these x's. That'll cancel out because that was the intention. All right, now with our y's, negative 8y plus 14y is 6y. 34 minus 22 is just 12. All right, we can divide by 6, and we get y equals 2. Now we can substitute it into any equation that we want. I'm going to shoot for this one because I can see that negative x, which we're going to solve for x here. We're only going to have to divide by negative 1 when we go to solve for this x. So I'm going to use the second equation. Plug 2 in for y. So now we're going to solve. So 4 times 2 is 8. Subtract 8. We get negative 25. Divide by negative 1. We get 25. All right, and then from there, we can just write the solution as an ordered pair. So we get 25, comma 2. Remember, for that ordered pair, it's x, comma y. So we got to remember to put that x first. All right, next one. If we take a look at D, notice none of these are direct multiples of the other. Right here, 2 is a multiple of 1, so this is pretty easy to figure out what to multiply by to create a set of opposites. If we don't have that here, remember, we can always create a set of opposites by just multiplying them by each other. All right, so if we shoot for getting rid of the x's here, so 3 times 2 is 6. All right, so if we multiply this equation by 2, we'll get 6x. But then we've got to get a negative 6x. All right, so 3 times negative 2 would give us negative 6x. Now I'm going to rewrite these equations. First one is this one when we're multiplying by 2. And we get 6x plus 8y equals negative 2. All right, now for this one, write that right there. If we multiply this equation by 3, we're going to get negative 6x minus 15y equals 30. All right, so the reason why we multiplied by 2 was to get a 6x, and the reason why we multiplied by 3 was to get a negative 6x. It's opposite. All right, now that we have those opposites, we're going to combine these equations, in which that's going to cancel out. 8y minus 15y is negative 7y. Negative 2 plus 30 is 28. We're going to divide by negative 7 to get negative 4. And then we're going to plug this negative 4 back into one of these equations. All right, so it doesn't matter, once again, which one you choose. I'm going to choose the second one, like I have been. So I'm going to copy this equation down. Instead of y, I'm writing negative 4. And now we're going to simplify and solve for x. All right, so multiply negative 5 times negative 4, and we get positive 20. Subtract 20. We get negative 10. Divide by negative 2. And we get 5. So the solution in this system is 5, negative 4. All right, last one. Here we go. Once again, got to clear the board. There we go. And just for fun, we're going to choose a different color. All right, and this last one, once again, doesn't matter which one you attempt to eliminate. You can eliminate either one successfully. I'm going to go for y because these coefficients are a little bit smaller. Okay, and if we take a look, One is not the multiple of another, so we're just going to multiply these together. That's a real simple and easy way to get a set of opposites. So 3 times 2 is 6. All right, so in one we have to have a positive 6y, and the other a negative 6y. Well, this is already positive, so 2 times 3 would give us that 6. All right, negative 3 times 2 would give us that negative 6. All right, so now let's just rewrite these equations. So when we multiply that top equation, we got 24x plus 6y equals 66. For that second equation, we've got 10x minus 6y equals 70. The whole point was to get opposites here, because now when we combine, we only have one unknown left. So 34x equals 136. And if we divide by 34, we get 4. Now from there, you can plug it into either one of these equations. It doesn't matter. Okay, so what I'm going to do is I'm going to plug it into this top equation this time. Change it up here. So instead of x, we're putting 4, and then we're just copying this equation as is, the original equation. All right, so now 8 times 4 is 32. Subtract 32, we get negative 10. Divide by 2, we get negative 5. So the solution here is for negative 5. All right, folks, that's about it. Remember, when we're finding the solutions to these systems, what we're doing really is finding the intersection point. Okay, so we're just finding that point by which they both intersect. And this is valuable in a lot of different ways. Okay, a lot of different examples. There's a lot of different real-life examples in which we want to know where do these intersections occur. Okay, this type of an example might be talking about like breaking even with a company, and then we want to know those 2 points so that we can find, maximum amount of profit. All right, so these are the types of questions that are important for the SAT. Also, remember day 2, we're going to talk about some more SAT style questions that goes along with this. All right, thank you. Hopefully that helped, and have a great day.